Good morning. Very excited to be back in Zadar. Actually, I've been working on my pronunciation. Do you mind if I give it a shot of this city? Zadar? Better? No? No? Okay. Well, I tried at least. Anyways, I'm very excited to be back. I was here in 2023, so 2 years ago. And I have to say, this is one of the most incredible and awkward stages to be able to rotate between two different audiences. And it was one of the coolest speaking opportunities I've had in my career. And it was such a highlight, but at the same time, it was actually a very stressful situation for me. I suffered my first and only anxiety attack. Ironically, I didn't suffer an anxiety attack because I was nervous about being on stage. Actually, when I got on stage, all of my anxiety completely disappeared. And then when I got off of stage, it immediately came back. And this ended up being so bad that I went home early, left early from the conference. And when I got home, went to the hospital. This is actually the band where I got admitted because I thought I was having a heart attack. I was terrified. There's lots of reasons, or there's a few different reasons for why this happened. One is that it turns out being a new father, it's hard to be completely on the other side of the world from your family, coming from the US. And so while I was here, before my talk actually, I told the staff, Sarah in particular from InfoBip, that I was having anxiety. I didn't really know what this was. This is completely new to me. And they were great. They rebooked me on an earlier flight to get home so I could be back with my family. And they handled that so beautifully. And I also have one other memory of sharing that experience with someone after the fact. I think it was several months after, and I told Tejas, who presented yesterday, I told him what had happened while I was here, because he was here. If you saw, we had a picture together. And he was like, dude, why didn't you tell me? We would have figured that out. And that was something that's always stuck with me, just to have that level of support from a friend and also from the staff. So all of that said, I just want to thank all the staff, everyone here, for the opportunity to be back and speak with you all today. Now, a lot has changed in 2 years. 2 years ago, I had a 6-month-year-old at home. And as any parent knows, going from 6 months to now 2.5 years, the challenges are drastically different, but they're also a ton of fun. And just for good measure, my wife sent me this picture since I've been here today. And also, at the end of next month, we're expecting our second. So again, parents of multiple kids can probably understand how terrifying that is, but very excited. So in addition to all these personal changes, after speaking here 2 years ago, I went to a conference in the US called Render ATL, and I spoke there. And I started to have a conversation, casual conversation, with a team at MakeSwift. And they were saying, hey, we're looking to hire a head of developer experience. And the more they talked, I was kind of interested. And they said, you know anyone that would be interested? And I said, well, actually, I would be interested in that. And what MakeSwift is a visual website builder. There's actually a hilarious video on makeswift.com if you want to check out the very satirical video and learn a little bit about what they do. But a few months later, I joined MakeSwift full-time. MakeSwift was a small startup of 18 people that had already been acquired by an e-commerce platform called BigCommerce, which I'll come back to in a second. And so when I joined, they were working on a project called Vibes. Now, this was before, or maybe right around the same time that the idea of vibe coding became really popular. But the idea of Vibes was a modern UI library for composable websites. And so as I thought about what has changed over the past 2 years, 2 years ago I talked about the impact of AI on developer experience. And I went to write a talk that was a part 2 of that, and then I looked at the list of talks and saw that everyone else was doing the same thing. So I decided to do something a little bit differently. I want to take you through the journey that we had in building Vibes and thinking about developer experience while building something amazing for the web. So my name is James Q. Quick. I am 3 things. I've done all of these professionally for 10, 11, 12 years now as a developer, a speaker, and a teacher. And I mentioned that I joined that small startup, MakeSwift, which is about 18 people. MakeSwift had already been acquired by BigCommerce, which is a SaaS platform. And then over the summer, we rebranded to a parent company called Commerce, which now includes all the products, BigCommerce as an e-commerce SaaS platform, MakeSwift as a visual website builder, and Feedonomics as a way to get your e-commerce data in the right places so it's discoverable on the internet. So what we tried to build, or what we wanted to build, was Vibes, which is a component library that supports the best of React and Next.js. How many React developers do we have? OK, a few. There will probably be a lot of new concepts in here, which will be good then. So we'll get to explore some of those. But we'll talk about some of the latest features in React, things like server components, streaming, suspense, server actions, and partial pre-rendering. How many people are using one of those in the code that you write? A couple, very few. On this side, a couple more. OK, cool. So we'll get to explore all of those, and we'll go through this journey of looking at what we're building and thinking about it from a few different perspectives. And basically what we want to do is build a modern component library that supports those features, supports suspense, streaming, and PPR with first-class experience. Now, experience here is very intentionally vague. What does experience actually means? Well, we could think about developer experience. We could think about what it's like for a developer that's consuming this library and building with it. We could also consider the user experience, what the performance is, what the rendering looks like, what the loading time of a user on a website that is built using this component library. But really what we want to focus on is both. And if we dive into the idea of developer experience, there's actually two different levels to this. There's the user, and this is the user of the library, so the developer that's consuming the library to build their own site. And then there's actually the author of the library as well. As you're authoring new components in this library, what does that experience look like for you? So there's lots of components and Vibes. In this case, we're going to focus on the product list component, which is relatively simple. And the idea is we want the user of this library to build something where they can have a loading skeleton and then load in their products that are available to be seen by whoever is visiting their site. So let's start to look at some code. In our homepage file, we have a relatively simple React component where we have a piece of static text. It just says my products. And then we have the product list component, and we pass that a list of default products. This is just a static array, just so we'll start simple. So a static array of demo product data. Now, loading static data is simple. This isn't a very realistic use case. It's not loading data from anywhere else, and it's not even pretending to. So let's start to work on that. And we can now introduce a concept from React called server components. Server components are a first-class citizen inside of Next.js. And what this means is that you can do something that for React developers has been considered blasphemy since this has been announced, which is the ability to run asynchronous code in React on the server. And what that means is from this basic home component that we have, instead of just passing it a hard-coded array of data, we can make this function async, and then we can simulate making a fetch request. We'll revisit this in a minute, but simulate making a fetch request using await and then having a delay in there of 2 seconds. And then we pass that newly loaded data to our component. Now, what's the problem with this? Well, data loading is blocking. And what do we mean by that exactly? That means that all of the data is loaded on the server before any markup is sent back to the browser. Now, the thing that may or may not stick out to you is there's certain components in your web applications that are not dependent upon the actual data itself. It's just a static piece of UI, in this case, the My Products header. That's just a static piece of HTML. It has no dependency on any of the project or products that get loaded asynchronously on the server. So how can we separate those things and allow the static piece to get sent down first and then stream in the results of the data as they're ready? And this is where streaming and suspense comes in. Suspense lets you display a fallback until its children have finished loading. So this way we can introduce the idea of that loading screen while that data is being loaded on the server, but the response to the browser initially is much faster because you get that static piece of data, and then you load in the dynamic data when it's ready. So let's now go to the products list component. This is going to be in the source code of Vibes. This is the actual component that you would copy and paste into your project. Inside the products list component, we have some props. As you can imagine, it takes a prop of products, which is an array. Now, from here, we can start to move our data loading into the product list component specifically. So what does that look like? Well, instead of accepting products directly, in this case now we can accept a promise that resolves to that product data. So we're moving that asynchronous loading inside of this component. And we'll see why in a second. Now from here, inside of our product list component, we can take the products that we receive as the parameter, we can mark our function as async, and we can await that promise to get the actual data back. Now the reason we had to move this into this kind of nested component is the way that suspense works. So inside of our home page, inside of our page.tsx file, we can now do a couple of things. We don't need to pass the data directly, which means we don't need to wait for this data to simulate being fetched. We can remove async from this function. We can remove await from this call, and then we can pass in our product data the same as we used to. Does anyone know what comes next? Be more likely to work in a React audience, but suspense, that's right. So now we can wrap our product list component with the suspense component. Now what that suspense component does is that it says inside of here, we're going to have some data that's loaded asynchronously. And it has the ability within the React ecosystem to wait until that's done. And also the key part here is that we can pass a fallback, and we can tell it what should be displayed while this data is being loaded on the server. And we can determine exactly what will show in the browser until that data is done. Now, what would this look like? We'll have, just in case that wasn't visible one more time, we show the loading products text, static piece of text that is on the browser waiting for that data to be finished being loaded on the server. When that data is ready, it streams in and it replaces that static piece of loading text. So we're doing pretty good. And this is where we start to iterate on this developer experience. Well, in this case, we require that whoever is the consumer of this library, whoever is the user of this library, we've required that they define their own version of a skeleton. How many people have designed skeleton, like loading skeletons for things they built in the past? Almost anything that requires data loading also requires a loading skeleton, right? So why don't we go ahead and build that into the library that we're providing people, because we know in the React and Next.js ecosystem, they're going to need something to use as a placeholder until their data is ready. So in this case, we can build it right into the product list component. We can then use this as a user of this component library by importing the product list skeleton. We can replace this hard-coded div with the text of loading, and we can now use the product list skeleton to display as our loader. Now we get to the point where we have this really nice loading experience. Data is still streaming in exactly as it was before. And that's really the goal of what we want to try to get to in this demo. But there's a lot more details behind the scenes of how we could really improve both the developer experience of the authoring developer of the library, the user of the library, and then the user experience of whoever is viewing this website. So what's the problem with this? Well, the problem is that it's all or nothing. What do I mean by that? In this case, this means that it's either static or dynamic. See, what happens is when we tell things to load on the server, that means that this page, this route as a whole, cannot be statically built. So a statically built page is one that at build time is completely built and finished. It's an HTML file. You can then replicate that and put that on a CDN across the world, instead of being generated on demand. So in this case, we've opted in to be dynamic, which means any request from a user to the site has to go to that destination server. Now, if we think about this geographically, loading times are directly proportional to the distance traveled. As many enhancements and improvements and amazing things we have in the developer ecosystem, we still can't beat one thing: the speed of light. We still have a dependency on how far the request has to travel to be able to get that data back, and the request times are directly proportional to that distance traveled. So in this case, let's say that we have a server somewhere in the US, a lot of especially companies based in the US, by default, when you deploy something to them, they default give you like US East 1 in Virginia or something like that. So let's just say that this application is deployed in the US, well, if I am a visitor, if I'm a user of this website in the US, I'm probably going to have a pretty good experience. That's not a very geographically far distance to travel to make that request and get that response back. But what if you're in Croatia? This is a totally different experience. I don't know exactly what the gap there is, but you can imagine that's probably 10 times as slow. Now, these are down to milliseconds, but milliseconds matter to people. So the fact that this request is having to go all the way across the ocean to go to the server to get a response back means it's going to have a drastically different response time than if I was making that request from inside of the US. Now, again, think about this from the perspective of we're authoring a library where we have no idea how people are going to use it. We have no idea where they're going to put their server. We have no idea if they're going to take advantage of some of the features we're going to introduce here. But we know that they might. Now, the goal is what if we could take those static pieces, remember that static piece of HTML, the My Products HTML? What if we could take that data, statically build it at build time, and deploy that on a CDN with nodes all across the world? Now, what if in this magical world, that means that the request in the US that I make from home goes to the closest node on the CDN, but also, if you make that request from somewhere in Croatia, it's going to find the nearest CDN node, which is much closer than the original server was that we just saw. And this is where partial pre-rendering comes in. Partial pre-rendering is a rendering strategy that allows you to combine the best of both worlds, static and dynamic. Now, this is a graphic from Vercel, which is the creator of Next.js. And inside of here, they kind of show you exactly what they mean. Well, in a regular application, it's not all static or dynamic. It's a combination. So if we look at this nav bar is static. But inside of this nav bar, we have a cart, which is dynamic based on the logged in user. So you can't pre-render that at build time because the user, you don't know who the user is and what their cart is. You have to get that dynamically. And then if we go down to the product information, maybe everyone is searching for the same exact product information. Maybe that doesn't change. Maybe that's completely static. But what additionally might change and need to be dynamic is recommended products based on the logged in user and based on their history of preferences and things they've bought in the past. So even in this one relatively simple example, there's a combination of two static pieces and two dynamic pieces. And again, as the creator of this library, we have no idea how people are going to use this in what scenarios and how many combinations of static and dynamic data they're going to have. So to be able to enable PPR, partial pre-rendering. Oh, also shout out, Matt, I don't know if you're in here. This is fully supported on Netlify, by the way. If you scan the link in the QR code, my website that it'll link you to is deployed on Netlify. Big fan, Matt. If you want to take advantage of this feature, you have to use the Canary version of Next.js, so it's not stable necessarily yet. You also have to do a couple of things. Inside of your next config, you basically have to add a config here that says, I want to use this experimental feature. And I think this is kind of a way for forcing the developer to acknowledge that it's experimental. Then inside of our page component file, we have to add one line. We have to export a variable called experimental PPR and set that to true. By default, this is set to false, even if you added that config that we just saw in a second. So you have to explicitly opt into this on every page. Now, what does this mean? Well, if we run a build of our application, we would think that this would give us a good idea that something partial pre-rendering and semi-dynamic, semi-static would be working. But if we run the build and then zoom in a little bit, you can see that this is actually marked as static. So if you look at the first route on there, the home page, it's marked as static with a little empty circle. So that's kind of odd. Why is that? Well, Next.js requires you to opt into something dynamic rendering by using one of these features. Cookies, headers, you can imagine those things are specifically dynamic. You can't know what the cookies and headers are for every request beforehand. And there's also a feature in here where you could use fetch, and that's what we'll do in a second. Now, the key here is in Next.js 14, they did a lot of automatic caching, a lot of very aggressive caching. In Next.js 15, they backed off of that, but they still do some automatic caching, which I think is not super clear. So what's happening right now with our application as is Next.js during build time is looking at, hey, we have this data, we're pretending to load it. Even though we're using suspense, we don't think it's going to change. So let's just go ahead and build that page statically, which is fair at this point. So now we need to give it something to know that we want to trigger this dynamic rendering. So in this case, instead of just simulating, faking this promise and adding a delay, we're actually going to make a fetch request to an API endpoint to get this data. Now inside of here, you can see we added a cache no store property, which basically says never cache this. This is the trigger for Next.js to say this needs to be dynamic. Now you can imagine the reason you would do this is because you're using headers, cookies, logged in user information to make recommendations, et cetera. So this is a simplistic example, but you can imagine why you would want to do this. So now when you run a build and zoom in, you can see that that home route is half filled in, half dynamic, half static, partial pre-rendering. Now what's interesting about this is probably the longest, like as I'm iterating through examples of the final result, this is probably the longest time I've spent, which is a few minutes, talking about all the details of PPR and all these things. And the reality is, to the user, it's kind of the same experience. Unless you're able to show the difference between making the request directly near the server versus someone making it from across the world, and then show the impact of how that speeds up to where these load times are consistent across the world no matter where you are by leveraging the fact that you have static assets deployed to a CDN. Now, what's the downside of this? Right now, we're requiring this to load data on the server. So using that async await that we added inside of the source code for the product list component, that means that that component has to be run on the server, but we don't know where the user wants to use this. We can't guarantee that they're going to want to do this on the server. So this introduces the React Use API, which is a new API which allows you to resolve a promise of some sort inside of a component, and it's not dependent upon running on the server or the client. It can run on both. And so inside of our product list component now, instead of awaiting that and having an async function, we can remove that tag, we can import use, and now we can just use products. And it works the exact same way, but now we're able to leverage the fact that we don't know where they want to run this code on the server or the client, so we support both. Now, what's the problem with this? Well, right now, we're requiring that they pass a promise still, but maybe they don't want to. So this is where we want to support asynchronous and synchronous data. We want to let the developer decide what they want to do. So inside of the product list component, instead of accepting a promise directly, we can accept either the data directly or the promise that resolves to the data. Well, that's kind of, it's not that bad, but it's kind of annoying to write that if you're thinking about authoring these components to support this across the ecosystem of these components. So we can create a utils file called stream. Inside of that, we can export this new type called streamable. And now we can update our props to not accept either or, but this more streamlined version using streamable for product. All right, so it's a little user experience or developer experience for the actual author of the library. So now, we can't use if it's not a promise. So now we have to add a little bit of hard-coded logic to say if it is a promise, use. If it's not a promise, just take the data directly. So what's the downside here? Well, now we're requiring the user to implement suspense themselves. So inside of the source code, you can see that the consumer of this still has to import the suspense component. What if we could handle that internally? So what if we created a products list wrapper inside of our source code for the component, and we expose that to the user, and now they can import that and use that instead of the product list component, and now they have a simpler experience. Well, what's the downside in that? That means that for every one of these components, and in Vibes we have 40 or so, every one of these components, we have to specifically create this wrapper. And do you call it a wrapper? Do you give it a different name? That's kind of awkward. So we decided to create a reusable wrapper inside of our stream utils. And it looks something like this. It has suspense built in. It has this use streamable component. And so the product list component for authoring this uses render props, which is an older pattern, but gives them internally the ability to have this reusable component that they can use for all of the different components that we have and also simplify that experience for the consumer Because now, instead of the product list wrapper, they can use product list just as they expect it to. So as we've gone through these iterations, this is still working the exact same, but all of the use cases that we're supporting has become greater and greater. And so there's one really interesting potential bug here, and it comes from not necessarily this code specifically, but another version of this code that we might write. So if you remember, we have this idea of we want to check to see, and isPromise is a helper function that's elsewhere in the utils, but we want to check to see if this thing is a promise. If it is, we'll use. If it's not, we'll just use the data. Well, someone might look at that code and say, like, OK, that works. Maybe there's a more streamlined way that I could do this. And a reasonable thing that you might do is do this. So you say promise.resolve on streamable. Promise.resolve will always return a promise. So even if the data was not a promise originally, it will turn it into one. And now we can use on that newly created promise. If promise.resolve, or excuse me, if streamable is already a promise, promise.resolve will just return that promise. That seems reasonable. This is also a similar concept that someone else at any point, whether author or user of this library, might introduce something similar to this. And so if we look inside of our page.tsx file, if we make a couple of changes, again, we don't know how the user of this is going to use it, the consumer of this library. We don't know exactly how they want to use it. We just want to support all of their use cases. So what if they did this? What if they decided to mark the home page as a client component, saying this thing we want to render on the client. It actually will render on the server first, but also will render on the client. And then also, what if they didn't want to pass a promise? What if they just wanted to pass data directly? What if they just did this? Maybe they have a static set of data from a JSON file that's embedded in the source code. I don't know. But what if they just wanted to pass that data and not load that asynchronously from somewhere else? Well, we get this interesting situation where we get a bug when we rerun the same thing with those three small tweaks, one inside of the source code, two inside of the page component. And it talks about an uncached promise. And so what happens here is promise.resolve, if you don't pass it a promise, it will create a promise. But since they're using useClient, it will generate that promise on the client, which will cause a re-render, which will create a new promise, which will create a re-render, which will create a new promise, and so on and so on. So how do we handle this? Well, we have to have some sort of caching for these promises. And so we can iterate through this check to say, we'll create a minimal promise cache. We'll look at the streamable promise coming in. We'll check if it is not a promise. If it's not a promise, we'll just return it. If it is a promise, we'll put it in the cache, and then we'll return the value of the promise from the cache. That way, there will be no infinite re-renders of this code, and we've solved that very niche bug. But again, we don't know how consumers of this library are going to use it, so we have to plan for everything that they might do, that we might want to support. And at the end of the day, this experience is exactly the same. And I guess maybe this is part of the moral of this story is the experience that you see at the end of consuming something. You might miss out on some of the details that go on behind the scenes of the thought process and the logic and all the things that people go through to create that sort of thing. Because this experience is still relatively simple. We've matched the same experience that we had 20 minutes ago, but now the use cases that we support, the bugs that we support or don't support, prevent, get greater and greater. So I know what you may be thinking as we wrap up in the last minute and 20 seconds. You may be thinking, how does this have anything to do with AI? Considering the fact that almost every talk here has had a tie into AI. And I think the general idea is that you could use AI to do a lot of pieces of this. You could use AI to iterate through the same process we just went through. You could use AI to generate a lot of the code, whether for the component library itself or the consumer using the library. You could do a lot of that with AI. But at the same time, it takes someone with intentional thought and the knowledge and the awareness of all those different things that we just talked about to guide AI in the right direction to get to the final result that we want. So in all the potential scare of replacing jobs and all the overwhelming amount of tools there are in AI, I just want to end with one note. And it is that your perspective is invaluable. AI has already changed and will continue to change the way that we work every single day. But your perspective, your opinion, and your experience is the thing that will ultimately leverage that to build good products. Thank you.